In the name of Allah, welcome back to another video uh, from my channel. So, in the last video, we have talked about preprocessing in ENVI, the preprocessing of satellite images. In this video, also we will talk about some important issues that will be applied on satellite images before starting processing and extracting information. So the most major things that we will talk uh, in this tutorial is the what is the subset that we have talked about this in the previous video. So why we have to subset an image? As I explained in the previous video, we subset an image to separate our study area, to reduce processing time. As I said, if we try to process all the image or a complete image that it has or it covers a large area, it would be difficult and will take a long time and need a great with a high quality component of computer. So when we subset an image, then it will be easier and also faster to process the image. So let me open the satellite image. All the bonds and component of this image through the multispectral file will be opened here. And the next thing, we're going to talk the threshold and ROI. So we will discuss on these things at the right time. Right now, so this is my image, and I'm going to subset this image. First of all, to do anything with this image, I'm sure that you remember this. I import a vector data, and so vector to ROI. I import a vector data, then change the vector into the ROI. Then I use this ROI to subset this image or to clip the image as my study area. All the records will be assigned as a single ROI. And you see here, this is my study area. I'm going to subset or clip this area. Just only extract this area. Subset by ROI, multispectral, and okay, I select my ROI. I'm going to mask the areas outside this ROI So I set this image as subset. Okay. It takes few minutes to be subsetted, and now is applying the mask here. Now I uncheck this, and now I have this area subsetted from this image. So now I'm going to apply the radiometric calibration. Now I change this. And okay. Just I wait for a few minutes to the radiometric calibration to be applied on this image. Now this image is radiometrically calibrated. So I uncheck this one. Now you see we have the only area of our study area. So I'm going to change the RGB color like this. You see here. One of the most important thing into the ENVI that we have is a spectral library. A spectral library is a spectral capability of the phenomenon on the Earth. It shows how much reflectance that every phenomena has in the specified interval of the wavelength. For example, maybe a phenomena like water shows higher reflectance and for example higher bonds or a higher wavelength, and in a low wavelength maybe it has less reflectance and vegetation and snow and other phenomena. So you can check according to the library which phenomenon has which type of reflectance and which bonds they shows the highest reflectance and which bonds or which interval of the wavelengths they shows low reflectance. So for this, here is a spectral library viewer, and you can find here various type of phenomena that's recorded here, the phenomenon. For example, when you click on the vegetation, you see various type of vegetations here, and when I search water here and I click here, you see various type of waters can be seen here. When I click on this, you see something like this. it shows different type of according to its composition. Here we have different type of waters, but it shows a similar attitude, a similar characteristics, that the water shows higher reflectance and lower wavelength. For example, the most point of reflection is starting, for example, from 1.235 here, and approximately the lowest or 0 upper than 1.23, and also the highest and the 1.75 here. And also if I check for vegetation, various type of vegetations we have here, you can see. And when you check, each of them exposes a specific wavelength or a specific attitude against the radiation of the solar. So whenever we check that, we have seen here the reflectance of the water, what's its application for. For example, let's check it again. Look, for example, this is water. This is the reflectance of the water. It shows low reflectance or low values and higher wavelengths. You see, in x-axis wavelength and micrometer and data value and y-axis. So, and also here, look at this. The first bonds are lower wavelength, or the first bond has lower wavelengths, and the bond NIR SWIR1 SWIR2 has higher wavelengths. For example, the SWIR2 has 2.2 micrometer wavelength, and also SWIR first has 1.2609, and also the NIR has a wavelength of 0.646. So if I check the SWIR reflectance for water or SWIR2, I can see the threshold for water, to separate the water covered area from my study area, to be removed my study area, or for specifying as a specific class of my study area, it's important. So what's threshold for? What's its application? We can specify a class, we can separate a specified class, we can set an interval of the value for separating the classes, or any other application you maybe consider, or various type of application of the threshold. For example, I'm going to separate the waters on my study area by setting a threshold. I apply a threshold here. When you type here threshold, bond threshold to ROI. So it says in which band you want to apply this threshold. I'm going to select SWIR2 because it has a longer wavelength. But you see, the reflectance or the repetition of the data values are this. It's higher and higher data values are like this, and the lower data values are like this. For example, 0.8 is the most repeated value in this bond. So as we checked here, the lowest wavelength and in higher wavelengths, the lowest data value in higher wavelengths is related to water. So I can select this match. Okay. Now from here, a ROI must be created. Now I select the data. Here is my ROI. Then I load it on the data of subset. Sorry, on the data, I'm going to load on this data. Radiometric. On this one. Oh my God. Once again, I applied this on the subset. Okay. Now you see all the areas covered by the water is selected, just only setting by simple threshold. And this is the river, and this area maybe contains the water and maybe has the same reflectance as water, and you can see here. And these areas has the shadows. Shadows considered in this threshold as a water covered area. So you can apply mask on these areas, or you can select these areas as water covered area, or you want to specify as a specific class of your study area. So you can set a mask value. If your threshold doesn't work well, you can change your values from mean and max here, and you can save it again, and you can apply it again. So I'm going to build a mask from this this ROI that I selected, or from the separated water here. I apply this on the file of radiometrically calibrated file and say OK. From here, I import the ROI as a mask layer. Okay. Then from this option, you can set you can set the area on or off. If you select the area off when you apply your mask, the selected area will be removed from study area. For example, these areas are selected as a water layer, and when I mask this area and when I turn it off like this, then when I apply this mask, all this will be removed from my study area. So let's create it. For example, mask. Open. Then OK. Now this is my mask layer. Has just two values. When I check its quick statistics, you can see here we have two types of data here. This number of the pixels has 0 value, and this number of the pixels has 1 value. And when I check here, you see this area has the value of the 1, and this area or water covered area has the value of the 0. When I apply this mask to one of my layers in this area, and this area will be removed from my study area. For example, I'm going to apply the mask. My input file, radiometrically calibrated image, and OK. Select the mask layer. We have the mask one here, this one, this layer, and OK. Masked layer. OK. Now when I turn off or uncheck the layers, other layers, all these layers, now you see the area with the masked layer that is removed from my study area, as you see. You see, this is the water covered area that I masked here. When I apply the mask, and it's removed from my study area. Now it's empty. When I change the RGB of the layer, you see no colors here. It means this area is removed from the study area. So what's ROI for? What is its application? Whenever you want to subset, as we did many times in this tutorial or in this video, on this image, for example, subsetting or clipping this image, you need to create a ROI or a region of interest. You must specify the region of your interest that would be your ROI to subset or clip your study area. One of the most important applications of ROI in ENVI. And to mask an area that we did it here, To train a classification, when we apply uh, a classification on our specified image, in that time we need to uh, train our classifier. And whenever you want to train your classifier, you need a region of interest or ROI as a point, as a polygon, or as any. And also, when you assess the accuracy of your classification, when you decide to specify the percentage of the efficiency or feasibility of classification, the percentage of the correctness of your classification, you need ROI. Then you can use it quite from here. You can click here, it will be created here. You can add a new ROI as this, and you can rename it from here. For example, tree, and or for example water or vegetation. And you can choose from here. It's going to be something like this, or something like this, a shape like a rectangle, or something like this circle, or a line, or point. And your points will be added here. So we will try this when we are trying to classify an image. So let me close some layers here. I'm going to close all my ROIs. I don't want to save this. And I'm going to close mask layer, and this mask layer too, and the subset layer. And the next thing that we need to do is atmospheric correction. Here we have various types of atmospheric corrections, but most of the time I prefer to use quark. And the question, why do I use quark, has a simple answer, because it is very simple and needs less parameters. Just you can specify your file and your sensor or your satellite. For example, this image is from Lancet, and all Lancets are has a single option here from Lancet, TM, ETM, and OLI. And you can specify the location of the destination, the file to be stored. Now the destination is okay. Local drive of the ENVI preprocessing, and the name is okay to Quark. And you can apply Uh, Atmospheric correction is not necessary for any processing. So, according to your necessity, you will decide to do atmospheric correction or not. Maybe most of the time you don't need to apply this, and you need to do some process uh, that that gives you uh, appropriate result even without doing uh, atmospheric correction. And most of the time you need to do some processing that needs and or atmospheric correction is highly recommended here. Now this is the image that is atmospherically corrected and applied the quark atmospheric correction. Now you see a better image here, and you can compare both of them. This is our first image, and this is our image after being corrected atmospherically. So the other atmospheric correction is flash. You can input a radiance image, it says which factor that you use for each bond. We need a scale factor for each bond, so I'm going to use 0.1 or 0.1 for each bond. Then you have to specify your type of image that we have. Multispectral images and hyperspectral. Our image is multispectral. Then you can select your sensor name, for example, Lancet 8. So it asks you the date of image acquisition. So I can check the file here. For example, this date, 2021, 31 March. For example, March 31. And the time of the acquisition of the your data, for example, you have to check out the file once again. 6:13 30 minutes and 27 seconds in the morning. Six 13 minutes 27. And also the latitudes are specified by itself now when you select the input file. So this is the altitude of the sensor or satellite, and this is the ground elevation. You can specify your ground elevation. For example, in this area must be approximately 1,500 1.5 kilometers or 1,500 meters, and model aerosol can be urban, tropospheric, and or I can select rural area. And in this part, atmospheric model, we have subarctic winter, mid-latitude winter, US standard, and subarctic summer, mid-latitude summer. And I can select mid-latitude summer. So in this area. And also and multispectral Now it's completed. It's here. In your data manager, you can load it. Now you can compare these two images. This is the image from atmospheric correction of the quark, and this one is the image that atmospherically corrected of the flash. However, I'm going to remove this, but I recommend in a simple processing most of the time try to use a quark atmospheric correction, because in this correction you need less parameters to be filled in, and the probability of making a mistake is so low. And maybe you remember about the pan sharpening bond. Whenever you want to increase the resolution of your image, for example, when I'm going to see the river, in most area the river is only 1 pixel here. If you try to make this better, you need to do pan sharpening, or you can create a fusion image from this atmospherically corrected image and your panchromatic bond. Do you remember about that? Here is our panchromatic bond. I'm going to load this, and you see that it has a better resolution here, and you can create a fusion image using this bond. I'm going to do this right now. Once I'm going to subset this bond by my ROI, and after that I will try to create a fusion, and once weighed out, subsetting a clamping study area from panchromatic bond. Let's try it. You have different type of band sharpening here. For example, Graham-Smith band sharpening, and then diffuse band sharpening, and spear band sharpening. And I select the first one, radiometric quark. Next, and the high resolution is, let me close this. And here it says select the low resolution multi-bond input file, and your low resolution multi-bond file is quark atmosphere correction, because we processed all this image. And now it's the time to select the high resolution of the image. And this is the panchromatic bond. This is our high resolution image. Then we say OK. And here our sensor is Lancet WLI. And you can select the method of the band sharpening. Nearest neighbor, bilinear, or cubic convolution. But I select bilinear, and the file format would be ENVI file, and I specify its location, and I name this file unsharp. Okay. And now the band sharpening image is created, but you see this is a fusion or a composition of the image in its real extent, not according to our study area. And let's try the next step. First of all, I'm going to subset the panchromatic bond of this image, and I'm going to subset this. Upon subset, and now we have this image, and I apply a radiometric calibration also on this. Radiometric calibration of the panchromatic. Even you can apply your atmospheric correction on this font tool before subsetting this image as your image. This is now our panchromatic font. So I'm going to pan sharpen this image with this one. So let's try it. Low resolution image, quark atmospherically corrected image, and the high resolution is fine sharpening. So the sensor is Lancet OLI and subsetted fine sharpening. Anyway, after creating an image fusion or fine sharpening, still you see dark values around your study area. So you must apply your fusion before your atmospheric correction, or otherwise you have to apply a subset after applying your fusion. It would be better. So thank you for being part of this video and watching this. I wish that we enjoy these tutorials. Thank you.